In the cold silence of deep space, an interstellar visitor defied everything we thought we knew. 3IATLAS did not behave like a comet. It moved with intention, exhaled poison at perfect mathematical intervals, and seemed to whisper back to the sun in rhythms that followed impossible geometry. Cameras failed when they looked too closely. Data vanished. The sky itself bent into patterns that should not exist. Each flare, each pulse, each moment of silence hinted at control, as though the object were alive or guided by something that understands numbers better than we ever could. Tonight we follow the trail it left behind. From its precise outgassing to its synchronized dance with solar storms, we uncover a sequence so exact it challenges the very idea of randomness. Stay until the end, because what we found suggests 3IATLAS is not just a comet. It might be a message. When scientists first mapped the outgassing of 3IATLAS, they expected to see randomness.
Comets are unpredictable things.
They vent, sputter, and flare depending on what part of their icy crust catches sunlight. But Atlas refused to behave that way. It exhaled in intervals precise and geometric, releasing gas only at specific distances from the sun. Those distances, when plotted, fell into a pattern that mirrored simple mathematical ratios. The first release occurred at 2.1 astronomical units, the second at 1.4, then another at exactly 0.9. The spacing was too perfect to be coincidence. The differences between each distance formed a sequence of near-exact fractions, as though the object measured its position with invisible markers. Natural bodies do not count. They melt, spin, and break. Yet this one seemed to know where it was. Astronomers were divided. Some said it was coincidence shaped by selective data. Others whispered that it looked deliberate, the kind of symmetry one finds in engineered systems. Outgassing is usually chaotic because the surface of a comet is irregular. Some parts heat faster than others, and jets erupt without order. But the data from 3IATLAS told a different story. Every burst aligned with a mathematical curve that could be modeled by a logarithmic spiral, the same form found in galaxies, hurricanes, and seashells. Nature loves spirals, yes, but not at such perfect intervals. The phenomenon first appeared in late measurements from the Pan-STARRS telescope in Hawaii. Technicians noticed that every major spike in brightness occurred when the comet reached certain harmonic points relative to the sun. The intervals matched the golden ratio with startling accuracy. When one analyst plotted the data over a solar distance graph, the pattern glowed with eerie clarity, a rhythm hidden in orbit. The discovery spread quietly among observatories. Teams from Japan, Italy, and Chile began comparing notes. Each confirmed the same intervals. The comet did not simply heat up as it approached the sun, it triggered itself.
Bursts of vapor came only at those harmonic points, almost like a machine running a timed sequence.
Some began calling it the clockwork comet. In one report, a researcher wrote that the precision reminded him of artificial satellites adjusting their orbits. The analogy was uncomfortable. A comet behaving like a spacecraft invited questions that most scientists preferred not to ask. Still, the numbers could not be ignored. The margin of error was less than 0.5% between outgassing events. That level of consistency defied any known thermal model. Even more baffling was the chemical makeup of the released gases. Spectrographic analysis showed that each burst carried a slightly different composition. The first contained mostly carbon dioxide. The next was dominated by hydrogen cyanide. The third included traces of metallic sodium and unknown carbon compounds. It was as though the comet was staging reactions in order, layer by layer, each release revealing something deeper inside. If this were a random body of ice, its chemistry should have been blended and messy. But Atlas seemed to peel itself open systematically, shedding its materials in structured sequences. It was less an explosion and more an experiment. One theory suggested that internal pressure pockets might have formed along a lattice structure inside the nucleus, releasing in geometric intervals as it rotated. That could explain some of the timing, but not the mathematical precision of the distances. The outgassing followed orbital position, not spin. It knew where it was in space, not just how it turned. At the European Southern Observatory, one mathematician noticed something else. The distances at which the outgassing occurred corresponded exactly to musical intervals when converted to frequencies. The first to the fifth, the second to the octave, the third to the 12th. The comet was not only venting, it was singing. Its movements were tuned like notes on a cosmic instrument. That finding caught the attention of astrophysicists studying resonance in planetary systems. Some proposed that 3IATLAS might be interacting with the solar magnetic field, releasing material whenever it crossed nodes of electromagnetic tension. If true, the comet could be using magnetic energy as a trigger. But that still left one mystery: why those nodes repeated in clean ratios instead of chaotic flux. When data from the TESS satellite came in, it deepened the puzzle. The light curve of Atlas revealed micro-fluctuations before each major outgassing. It was as if the object were building up to each release, charging internally, then venting at precise intervals. The timing of those fluctuations fit into a perfect geometric progression. No natural process should behave like that. Several universities ran simulations. None could recreate the precision without inserting some form of regulatory mechanism. To make a comet vent that way, you would need internal sensors measuring distance, timing, and solar flux. Something capable of knowing its position relative to the sun. That suggestion sent shivers through every team that dared to entertain it. There was one more anomaly. After each outgassing event, the comet's trajectory adjusted slightly, always in the same direction, always by the same fraction of a degree. Those shifts accumulated into a path correction, so gentle that it looked planned. The releases were not just random vents of gas. They were thrusts, subtle, measured, controlled. The realization was staggering. Each burst of vapor acted like a miniature engine burn. Over time, the sequence of releases guided the object's motion as though it was steering. And because the releases occurred at precise distances, it followed a kind of cosmic navigation chart invisible to us. The object was propelling itself along a geometric route through the solar system. Skeptics insisted it was coincidence wrapped in human pattern seeking. Yet, as more data arrived, the sequence only strengthened. The distances between bursts matched not just mathematical ratios, but physical constants. One analyst overlaid the pattern onto known orbital harmonics of the planets and found perfect intersections with Earth, Venus, and Jupiter. The comet's outgassing events occurred exactly when it crossed lines of gravitational equilibrium between those worlds. In other words, the object released material at the points where the sun's and planets' gravity balanced most precisely. No known natural process could predict those spots in advance. It was as though Atlas had been programmed to respond to the hidden geometry of the solar system. When word of this leaked to the public, the idea of a controlled comet spread quickly. Most scientists avoided comment, but the private correspondence between researchers told a different story. They were frightened, not because of what the comet was, but because of what it implied. If this object followed mathematics across interstellar space, it meant that somewhere, someone or something understood our sun's architecture long before we did. Later in the year, when the comet moved behind the sun, the outgassing ceased entirely. Instruments recorded no residual activity, no tail, no thermal emission. It was as if the object went dormant once it reached a predetermined threshold. That silence was almost as strange as the precision itself. Whatever powered those releases had stopped, waiting perhaps for another geometric cue. In private meetings, a few astronomers speculated that the distances corresponded to energy nodes, points where cosmic radiation, magnetic flux, and gravitational balance intersected most efficiently. A natural body could not know such points, but a probe built to harvest energy might. Others tried to find comfort in simpler explanations. Maybe the internal structure of Atlas contained layers that sublimated at specific temperatures, each reached at different distances from the Sun. But when models tested that theory, they failed to reproduce the measured precision. Temperature variations alone could not produce such regularity. By now, the phrase mathematical outgassing had entered the lexicon of fringe science. Yet even mainstream institutions quietly continued to track it. The pattern had become undeniable. The ratios between outgassing distances remained constant across every observation. Something inside the object was counting. The last confirmed event before Atlas slipped into obscurity came as it crossed 3.4 astronomical units outbound. Observers recorded a faint but distinct final burst of material, smaller than before, yet perfectly timed according to the same harmonic spacing. Then it vanished. No further activity was detected. The comet faded into the background of deep space, leaving behind only its numbers: 2.1, 1.4, 0.9, 0.6, 0.4, 0.3. The sequence reads like a code, each step smaller than the last, converging towards something unseen. And perhaps that is the lesson 3IATLAS left behind. In its quiet rhythm of release, it revealed that the universe may operate with intelligence written into motion itself. Where we see distance, it sees measure. Where we see randomness, it sees design. If the object truly counted its way through the solar system, then its purpose may not have been to visit at all, but to calculate, to trace geometry through gravity, and to leave behind a trail of numbers that only those who watch carefully enough will ever notice. Something strange began to appear in the motion logs of 3IATLAS. At first glance, its trajectory seemed predictable, following the graceful curve of celestial mechanics. Yet, as astronomers looked closer, they noticed subtle deviations that made no sense. A comet born from interstellar space should obey the same laws as any other body moving through the Sun's gravity. But Atlas appeared to shift, to nudge itself, to slide in ways that suggested a hidden intent. These drifts were not random. They occurred in timed bursts, short intervals of movement that created micro-adjustments along the path. Some compared it to the behavior of spacecraft executing course corrections. The difference was that this object had no known propulsion system. No visible jets or sustained outgassing could explain the precision of these changes. What emerged instead was a quiet pattern, a pulse of motion that resisted the simplicity of nature. The first recorded anomaly came from a set of observations near the midpoint of its inbound journey. When plotted on a trajectory graph, the motion appeared to flatten slightly against expected gravitational pull. It was subtle enough that early analysts blamed data noise or instrument calibration. But as new readings came in from independent observatories, the anomaly held steady. The path seemed to defy pure ballistic motion. Comets often produce what scientists call non-gravitational forces. Jets of vaporizing ice can push them off course by fractions of a degree. But the math behind Atlas refused to match those models. The amount of force required to create such controlled motion would have needed a series of perfectly aligned vents, firing at just the right times, with energy output far above what its mass could produce. The odds were almost absurd. Some researchers suggested that maybe 3IATLAS carried a denser core or an internal magnetic field that influenced its travel. Yet no natural composition could account for the way it seemed to anticipate corrections before they were needed. It did not drift aimlessly and then react. It adjusted as though it had foreknowledge of its future position, like an object steering itself, not being pushed. A team from the European Space Observatory noticed another strange signature hidden within these drifts. Whenever Atlas made one of its slight turns, the surrounding dust cloud brightened momentarily, as if reacting to a burst of internal energy. That glow would fade back to normal almost instantly. No telescope caught the spark directly, only its aftermath. Some called it a coincidence of sunlight angles. Others wondered if something beneath the surface had briefly activated. When scientists tried to model the behavior using standard physics, the numbers broke apart. One simulation showed that for the observed motion to occur naturally, the nucleus would have to vent gas from opposite poles at speeds exceeding anything seen before. Another required rotation period so rapid that the comet should have torn itself apart. The only consistent explanation was an unseen process guiding it. Then came the radar returns. Several arrays noticed flickering echoes that hinted at surface irregularities moving independently of the comet's rotation. Imagine panels or ridges that shift their orientation mid-flight, changing how solar radiation strikes them. The idea was dismissed quickly as data interference, yet one analyst quietly noted that such a system could produce exactly the type of drift being recorded. The comment was buried deep in the technical notes, but it sparked quiet discussion in closed astronomy forums. As the object moved deeper into the inner system, its velocity should have increased predictably. Instead, it wobbled. The difference was not dramatic enough to shock headlines, but it was clear to anyone studying the raw numbers. The acceleration graph rose and fell in deliberate waves. The shape of that curve was eerily similar to controlled burns used in orbital mechanics. Each rise looked like a push, each fall like a stabilization. By this stage, whispers had begun to spread among independent observers. If the motion of Atlas was being guided, then the guiding hand might not be natural. Could it be reacting to our observation? Could it be testing the limits of visibility? These questions remained unspoken in official channels, but they circulated privately in late-night emails and encrypted message threads. Even NASA's internal analysts noted that the pattern resembled what they called adaptive trajectory shaping. That phrase usually appears in documents related to autonomous probes. It describes how onboard systems adjust their flight to conserve energy or align with a distant target. The resemblance was enough to draw uneasy parallels. Yet how could a lump of rock and ice perform something that mirrored deliberate navigation? Some argued that perhaps the answer lay in resonance effects. Maybe the object passed through magnetic zones or solar wind structures that nudged it periodically. But those same regions affect every comet that enters the system, and none show the same behavior. The solar environment is chaotic, not rhythmic, yet Atlas moved as if it could hear a metronome ticking through the void. What deepened the mystery further was the timing of its shifts. Many occurred when observational coverage was weakest. Periods of telescope downtime, moments when cloud cover or solar glare interfered, almost as if whatever caused these drifts preferred to act unseen. When the next window opened, the comet would appear slightly off its expected mark, yet perfectly stable once again. During one of these intervals, a university in Japan recorded an odd fluctuation in background radio noise. A short broadband pulse lasted less than 2 seconds and came from the region of space where Atlas was last confirmed. The data was not strong enough to classify as a transmission, but its timing matched the start of one of the trajectory corrections. It was written off as interference from solar activity. Still, a few researchers saved the file privately, unsure whether they had captured something intentional. The pattern of movement continued even as Atlas approached perihelion. Each micro-adjustment aligned it in ways that optimized solar exposure on one hemisphere. Comets do not care about symmetry, yet this one seemed to maintain it. If the behavior were random, the energy distribution would look chaotic. Instead, it followed ratios close to one used in controlled attitude stabilization, numbers that belong to design, not chance. After it passed the Sun and began its outbound journey, scientists expected erratic spin from the heating cycle. Instead, the rotation slowed slightly and stabilized again. The new trajectory was smoother than before, almost refined, as if the object had learned from its inbound passage. That word, learned, bothered many researchers, yet it was difficult to ignore the implication that each drift correction was building toward a form of optimized travel. This was when the term controlled entity first surfaced in classified research notes. The phrase was not used in press statements, but it appeared in internal documents that later leaked into online discussions. The suggestion was not that Atlas contained technology, but that its motion carried the fingerprint of intention. Some began calling it the intelligent signature, a pattern that points to guidance without revealing the guider. Skeptics insisted the data was being overinterpreted. They said human brains see control where there is only coincidence. Yet even the skeptics could not fully explain the repeating intervals or the precise synchronization with solar events that followed. Every new data set added another layer of curiosity instead of clarity. In the end, what began as a small irregularity in motion became a symbol of something larger, a reminder that in the vast clockwork of space, even one object behaving slightly out of tune can change the rhythm of how we see the universe. The question left behind is not whether 3IATLAS is alive or engineered. It is whether the laws of physics can sometimes behave as though they are listening. And if that is true, then every drift, every subtle correction, every silent pause in its path might not just be movement. It could be communication in a form we have yet to learn how to read. The first time scientists noticed the strange rhythm in 3IATLAS's tail, they thought it was a glitch in the photometric data.
A brief flash, a dip in brightness, then another glow rising from the void.
Comets often flare when sunlight strikes fresh ice, or when internal pressure causes brief bursts of gas. But this was different. The light pattern was too neat, too structured, and it repeated with unnerving precision. Every few hours, a flicker pulsed across its tail, like a silent heartbeat echoing through the darkness. Astronomers began comparing their observations from around the world. To their surprise, the timing matched almost perfectly between telescopes thousands of miles apart. Even after accounting for atmospheric interference and observational error, the data remained synchronized. Atlas was blinking. Not randomly, not chaotically, but as if following a hidden clock. A comet's tail is usually a product of chaos. Solar radiation slams into volatile material, blowing it outward in great streams of gas and dust. The light reflects off these materials unevenly, creating shimmering waves that dance in unpredictable ways. But this tail behaved as though it had discipline. The flickers arrived on time, the intensity rose and fell like a coded pattern, and each cycle appeared to align with tiny fluctuations in the object's trajectory. Some researchers at first thought it might be a natural resonance effect. Perhaps rotating jets of gas created pulses in brightness as the comet spun. But that theory quickly fell apart. For the timing to be so precise, the rotation speed would have to be stable to the second, which is unheard of in cometary behavior. And even if it were, the pattern would eventually drift. It never did. The blinking continued, unaffected by the comet's changing distance from the Sun or its varying speed through space. When NASA's test satellite examined the object's brightness curve, the pattern grew even stranger. The tail pulses carried harmonic relationships that looked mathematical. Ratios between intervals appeared consistent, hinting at modulation rather than randomness. It looked less like sunlight bouncing off dust and more like a signal being encoded into light itself. The idea of a signaling comet sounds absurd, yet the deeper the data analysis went, the less absurd it became. One team at a European research center ran Fourier transforms on the light curve to look for repeating frequencies. What they found shocked them. The intervals between peaks formed clean integer ratios, the kind found in engineered transmissions. Nature can create patterns, but it rarely makes them so neat.
There was rhythm where there should have been noise.
The team hesitated to publish. The term intelligent signature was already circulating quietly among astronomers who studied 3IATLAS. Some feared being ridiculed if they suggested the tail's pulses might not be natural. So the initial papers described it cautiously as anomalous periodic variability. Still, the phrase did little to hide the unease behind it. Meanwhile, amateur astronomers across the world began reporting their own observations. Some recorded the object with backyard telescopes, stacking long exposure frames to capture every flicker. They noticed that the blinking seemed to occur more strongly at certain angles, as though it were directional. When Earth crossed the plane of its orbit, the brightness peaks flattened. When the viewing angle changed again, the pulses returned. It was as if the comet was sweeping a beam across the solar system, and occasionally Earth stood in its path. If this were a natural process, it was one the textbooks had never described. Even comets with highly active jets produce irregular flashes, not rhythmic signals. So what could cause this? A popular theory emerged that the blinking might be the result of plasma interactions between the comet's ion tail and solar wind streams. When magnetic fields reconnect, they can produce bursts of light. But even plasma chaos cannot stay this consistent for so long. The regularity defied every model. Further investigation revealed that the pulses seemed to correlate with changes in local solar activity. Each brightening coincided with microflares or particle flux spikes recorded by satellites near Earth. It was as if 3IATLAS were responding to solar fluctuations in real time. When the sun exhaled, the comet blinked back. Some began to wonder whether it was not merely reacting, but synchronizing, forming an unseen feedback loop across millions of kilometers. Data analysts began mapping the timing of these blinks against the trajectory anomalies noted earlier. That was when the deeper pattern emerged. Every time the tail brightened, a subtle change in velocity followed. The light pulses and the trajectory shifts were not separate events. They were connected, part of a larger behavior that implied control. The idea of a controlled outgassing cycle began to surface. Perhaps the comet's internal chambers vented gases in an oscillating pattern, releasing energy in discrete bursts that both adjusted its motion and caused visible brightening. But if this were true, the precision of the timing would mean those vents operated with mechanical accuracy.
Nothing in the natural world behaves that way.
In secret correspondence later leaked online, one astronomer compared the behavior to a form of communication through motion and light. If we assume intent, he wrote, then every blink is a syllable and every drift is punctuation. It was not a declaration of belief, but an acknowledgement that the data looked more linguistic than geological. When the comet passed behind the sun, telescopes lost sight of it for several weeks. During that blackout, several ground-based observatories picked up faint radio fluctuations near its expected position. These were not strong enough to be signals, but their timing was curious. They followed the same rhythm as the optical pulses had. Even without direct line of sight, the pattern somehow persisted, now embedded in the electromagnetic noise of space. By the time the comet re-emerged, the blinking had changed. The pulses were shorter and slightly more frequent, almost like a new sequence. It was as if whatever was controlling them had updated the rhythm. The shift did not match any known physical cause. It was deliberate in timing and consistent across all frequencies of observation. Theories grew wild. Some claimed it was a natural plasma oscillator. Others whispered about an embedded object, perhaps something artificial hiding within the coma. One speculative report even suggested that the tail might act as an antenna, modulating sunlight and charged particles into a repeating broadcast. There was no proof of this, but the speculation caught fire across scientific forums and conspiracy boards alike.
One undeniable fact remained.
The blinking stopped exactly when a major solar storm erupted. The storm was powerful enough to disrupt satellite telemetry across several networks. When the skies cleared and observation resumed, the pulses were gone. The tail faded to a steady glow like a machine that had powered down. This sudden silence sent ripples through the research community. It was as if the object had chosen to go quiet right when the sun's interference made observation impossible. Once again, the timing was too perfect to be coincidence. The idea that Atlas might be listening became a whisper passed quietly among teams studying it. Weeks later, a smaller flare reignited the tail, and to everyone's shock, the blinking resumed. The same intervals returned, the same brightness ratio, the same eerie rhythm. It was like a heartbeat starting again after a long pause. The synchronization with solar events now seemed undeniable. It was as if the comet's behavior had been waiting for the right frequency, the right environmental cue to reactivate. By then, the question was no longer whether Atlas was behaving strangely, but what it was responding to. Was it resonance with the sun's cycles, a kind of cosmic echo chamber, or something more directed, something tuned to signals invisible to us? Scientists continue to debate it, but one unsettling truth remains. Light is information, and the tail of 3IATLAS is sending something across the void. Whether that message is a side effect of nature or a deliberate act, no one can yet say. But the precision is undeniable. A comet that blinks with purpose forces us to ask the hardest question of all. What if the universe has been speaking all along and 3IATLAS is the first voice we have learned to notice? It began as coincidence. At least, that was how scientists explained it the first few times 3IATLAS flared. At the exact moment, the sun unleashed a new burst of energy. A solar flare erupts, and within minutes, the comet brightens in response.
Another eruption, another glow.
At first it seemed harmless, but then the pattern started repeating with mechanical precision, and the timing became too exact to ignore. Solar events are unpredictable by nature. Flares, coronal mass ejections, and radiation spikes follow the chaotic dance of magnetic fields twisting and snapping on the sun's surface. Yet somehow, this lone interstellar object seemed to know when the next wave of solar energy would erupt. Its tail, its outgassing, even its spectral emissions all appeared to move in rhythm with solar storms. Scientists who monitored solar weather were stunned. Normally, it takes several minutes or even hours for the effects of solar radiation to reach a comet. But in the case of 3IATLAS, its reaction was nearly instantaneous. Brightening often occurred within seconds of solar activity recorded on Earth's satellites. That kind of timing made no physical sense. The distance alone should have caused a delay, yet the comet always responded first. It was as if it anticipated the events before they happened. At the Solar Dynamics Observatory, analysts began cross-referencing solar flare timestamps with the light fluctuations from 3IATLAS. The overlap was uncanny. When plotted on a timeline, both curves, solar and cometary, rose together in perfect symmetry. The odds of such consistent alignment occurring by chance were infinitesimal. Some began whispering that perhaps the comet was not reacting at all. Perhaps it was triggering. In a small meeting room at the European Space Agency, a group of researchers gathered to review the correlation data. The conversation started with cautious curiosity but slowly turned uneasy. The timing was just too tight. One scientist compared the synchronization to a feedback loop between two linked devices. The sun erupts, the comet glows, and then, bizarrely, the sun appears to echo back with another smaller flare minutes later. It was like watching two entities exchanging signals across space. Still, the rational explanations came first. Maybe it was electromagnetic coupling, or a coincidence amplified by data bias. After all, both solar and cometary activity peak during certain conditions. But those same researchers soon discovered that Atlas's synchrony continued even when solar activity dropped to near silence. It would flash faintly, and then, moments later, a flare would bloom on the sun's surface in the exact magnetic region that aligned with the comet's orbital path. It no longer looked like a reaction. It looked like communication. Radio astronomers joined the study next. They noticed that around each synchronized flare, Earth-based receivers picked up subtle disturbances across a wide range of frequencies. The disturbances were short, structured, and appeared to originate near the Sun-Comet line. One engineer described them as digital-sounding bursts in the static. There was no proof that they came from Atlas, but the timing aligned too cleanly to dismiss. The question no one wanted to ask out loud began circulating through encrypted messages between observatories. Could something inside 3IATLAS be responding to solar signals intentionally? Or worse, could it be using the sun as an amplifier? By the time the comet reached its closest approach, the timing phenomenon became undeniable. During one of the largest solar storms of the year, Atlas's entire coma brightened in sync with a massive coronal ejection. As plasma surged outward from the sun, the comet's ion tail rippled like a living filament, glowing brighter than ever before. The motion of the dust cloud formed spiral shapes that seemed to trace magnetic field lines invisible to the eye. Every change in the solar wind found an echo in the comet's movement. At first, this was seen as a perfect example of solar-comet interaction. But then the sequence reversed. Hours later, the comet brightened again, and seconds after that, a new magnetic storm appeared on the sun's surface, originating exactly at the latitude that matched Atlas's projected line of travel. A reversal of cause and effect. The comet was now acting before the sun, not after. When the data reached NASA's Goddard Space Flight Center, the analysts rechecked every timestamp. They found no errors. The synchronization stood. Some called it the most disturbing data set they had ever processed. Others quietly deleted their copies, unwilling to attach their names to something that could not be explained. A physicist from Italy proposed a bold theory. What if Atlas was capable of detecting solar instability before it erupted, reacting to magnetic flux in the heliosphere? That might explain why it always seemed to move in harmony with solar activity. But that would also imply the comet contained a system or material sensitive to magnetic variations on an impossible scale, an awareness of solar physics more advanced than anything known to nature. Meanwhile, independent researchers began comparing Atlas's timeline with other cosmic phenomena. To their astonishment, several high-energy neutrino bursts recorded near the same dates also matched the comet's flickering cycles. It was as though the synchronization reached beyond visible light, linking electromagnetic, magnetic, and particle domains into one giant network of reactions. There were moments when the timing grew so precise, it seemed scripted. During a 2-week window in which Earth experienced mild auroras caused by solar winds, Atlas pulsed in perfect step with the rhythm of the Schumann resonance, Earth's own electromagnetic heartbeat. The connection spooked even the most skeptical scientists. How could an interstellar body millions of kilometers away pulse in rhythm with both the Sun and Earth's natural frequencies? The implications were staggering. Soon the debate shifted from coincidence to intent. If the timing was not random, could it be evidence of coordination? Some suggested a form of passive intelligence, an entity not conscious in a human sense, but reactive, designed to communicate through cosmic forces. Others argued it might be a probe, one that transmits through light and magnetism instead of radio waves. As weeks passed, more evidence piled up. Whenever the sun's polarity flipped, 3IATLAS adjusted its brightness pattern slightly, as though retuning itself. During these shifts, ground instruments detected low-frequency hums that echoed across the ionosphere. People began to report unusual static in radio channels during each synchronization event. The entire solar system seemed to buzz in sympathy when Atlas blinked. But perhaps the most unsettling moment came when researchers predicted the next solar event based on Atlas's pattern, and were correct. They forecasted a flare, its location, and its timing solely from observing the comet's rhythmic behavior. When the sun responded exactly as predicted, a heavy silence fell across the scientific community. For the first time, the comet's light had become a forecast tool, a predictive engine for solar activity. Something was connected, something that should not be. Theories began to fracture into two camps. One saw the comet as a passive instrument, a natural sensor from another system that reacts to energy the way a tuning fork vibrates to sound. The other believed it was a designed object, placed with precision to monitor or manipulate energy across stellar environments. Both sides agreed on one thing: the synchronization was real, measurable, and impossible under known physics. As the sun rotated and the alignment faded, the rhythm slowed and the light pulses weakened. The solar flares became less frequent, as though the dance had ended. The silence that followed felt deliberate. It was as if both participants, the comet and the star, had finished their dialogue and returned to quiet observation. Even now, the datasets remain stored across multiple agencies,
Analysed and reanalyzed, yet never fully explained.
The official reports call it an unusual but natural resonance. Off the record, many scientists use a different phrase. They call it a handshake in light. Perhaps 3IATLAS was not a random visitor at all, but something that had waited for the right solar conditions to reveal its purpose. Maybe what we witnessed was not coincidence, but choreography. If so, then somewhere in that perfect synchrony between a comet and a star lies the trace of intent. A silent conversation written in radiation,
Unseen by most, but undeniable once noticed.
and perhaps in the quiet after the final flare, the sun itself whispered back. It was supposed to be the moment of truth. Every major observatory across the world had prepared to capture 3IATLAS at its closest and brightest. The timing was perfect, the geometry ideal, and the instruments were ready. Yet when the moment came, the world's best cameras failed to deliver. Images vanished, live feeds cut to black, and data streams froze as if someone had pressed pause on the universe itself. At first, it looked like bad luck. A solar flare here, a telemetry glitch there. But as the failures piled up, a darker pattern emerged. The best equipment, the most advanced sensors, were the ones that stopped working. Lesser systems, older cameras, and amateur telescopes continued recording. Their images were grainy, imperfect, and strangely empty. The high-resolution views that should have shown fine details instead went missing. The first blackout came from NASA's Psyche probe, which had been perfectly positioned to capture the comet during a narrow observation window. Telemetry showed the probe active and stable, but its main optical feed went dark for 21 minutes. When it returned, the comet had already passed through its closest phase. The missing segment coincided exactly with a sudden spike in the probe's radiation sensors, followed by a hard reset. Engineers called it a coincidence caused by cosmic interference. But there were other coincidences that same night. At the same moment, two ground observatories, one in Chile and another in Hawaii, reported corrupted image files from their adaptive optic systems. The data would not open, and when finally recovered, the frames showed static where the comet should have been. No stars, no tail, just a grey smear, as if the sky itself had been erased.
Even stranger, all backup recordings from that hour were incomplete.
Their metadata indicated they had been written and overwritten several times during the event. Researchers tried to blame solar storms, but space weather logs showed no major disturbances. The atmosphere was calm, the network stable, and the instruments functional. The silence had no technical reason. It was as if the cameras simply decided not to see. The pattern continued in the days that followed. The Hubble Space Telescope attempted several exposures, but the files never made it into public archives. Each attempt returned an instrument timeout message. When questioned, officials claimed the observations had been postponed for calibration. Yet the scheduling logs tell a different story. The exposures were taken, the data was processed, and then without explanation, the images were classified. That decision drew immediate suspicion. Hubble rarely withholds cometary data. Even unusual observations are typically released within hours, but 3IATLAS became an exception. The few images that did appear were cropped, low contrast, and oddly featureless.
A faint glow, a dust trail, and nothing else.
Gone were the intricate jets and surface details seen in other interstellar visitors. It was as though someone had blurred the truth out of existence. Meanwhile, amateur astronomers kept watching. Many expected to see the same brightness patterns, yet their equipment seemed strangely affected as well. Cameras that had functioned for years began freezing at random intervals whenever Atlas was in frame. A few even reported brief static bursts on their monitors, thin horizontal lines that pulsed like interference from an unseen signal. None of these effects appeared when filming other objects in the same sky. On astronomy forums, whispers began circulating. Some users suggested that the object emitted electromagnetic interference strong enough to disrupt optics and sensors. Others speculated that the blackout was artificial, a deliberate suppression from an unknown source. A few compared it to military satellite masking, where live imaging is automatically filtered or redacted when certain signals are detected. Then came the most disturbing incident. The test satellite, designed to record precise light curves of celestial bodies, experienced a sensor lock while focused on Atlas. For 7 minutes, its detectors returned flat readings, no fluctuations, no data. When the system recovered, the light curve showed a sharp spike, like a burst of light too bright for the instrument to process. But that spike never appeared in the transmitted images. It existed only in the raw telemetry. Data analysts later discovered that during this blackout, a brief surge of unknown origin hit several ground receivers. The signal resembled encrypted communication packets but carried no identifiable pattern. Some wondered if the comet had produced a sudden flash of radiation that overloaded sensors across multiple observatories. Others believed something far stranger had occurred. Selective blindness. Why would the universe hide itself from our best eyes? The question echoed in private conferences and encrypted calls between agencies. One astronomer described it as a wall of silence surrounding precision. The more advanced the optics, the deeper the blackout. It was almost as if something aboard or within the comet recognized being watched and chose when to disappear. Several attempts were made to bypass the interference. Infrared telescopes in orbit around Earth tried to observe the object at different wavelengths, hoping to catch what visible light missed. But the results were the same. Every frame taken during the anomaly window was corrupted or lost. When the instruments returned to normal targets, they performed flawlessly. The silence reached its peak during what should have been the clearest observation period of all. The James Webb Space Telescope had a direct line of sight to Atlas during a crucial alignment phase. The images were expected to reveal the object's molecular structure in unprecedented detail. Instead, the telescope's onboard computer reported data acquisition pause. That pause lasted exactly 12 minutes and 20 seconds. When the system resumed, the comet had already drifted out of range. No one could explain the timing. The same phenomenon repeated during follow-up attempts. Each time the telescope locked onto Atlas, its instruments would briefly stall. The Webb team later confirmed privately that no other target had caused similar interruptions. It was unique to this object. As pressure grew for answers, agencies released short, carefully worded statements. They spoke of temporary data inconsistencies, solar contamination, and instrument recalibration. But within the scientific community, those phrases became a code for something else, an unspoken understanding that the truth was being managed. In underground data archives, a handful of leaked files began to circulate. They showed blurred outlines that hinted at geometric features within the comet's coma, straight lines, angles, and sharp reflections not typical of natural ice. The authenticity of those files was never confirmed, yet they fueled the growing suspicion that something had been deliberately removed from public view. Months later, when independent researchers requested the missing datasets through open access channels, they were told the archives were incomplete. Several drives had been corrupted during storage, and backup copies were unrecoverable. That phrase became infamous among the few who still tried to study the object.
Unrecoverable, as if the universe itself had chosen amnesia. The silence around 3IATLAS became louder than any discovery.
The blackout periods, the missing frames, the corrupted archives, all pointed to a coordinated absence. Whether natural or engineered, the effect was undeniable. The object existed only when it allowed itself to be seen. One independent astrophysicist proposed that the comet's surface might possess materials capable of electromagnetic cloaking. bending light or absorbing radiation at key wavelengths. Another argued that if 3IATLAS were artificial, it could easily project interference to blind cameras that reached a certain resolution threshold. Both theories were dismissed publicly, but quietly studied in private labs. The final confirmation of this selective silence came unexpectedly. A small observatory in Argentina managed to record a brief, crystal-clear sequence before its instruments shut down. For less than 2 seconds, the image displayed a shape inside the coma, an object with clear symmetry, possibly hexagonal, glinting against the black. The frame cut off instantly after that. The system rebooted as if nothing had happened. The observatory reported a minor software crash, but the operator swore he never touched the controls. That frame circulated for weeks before disappearing from public networks. Those who saw it described it as mesmerizing and unsettling, a glimpse into something both mechanical and alive. Some claimed it was proof that 3IATLAS was not just a comet, but a vessel or probe, hiding beneath a shroud of dust and gas. Others insisted it was nothing more than a glitch, magnified by imagination. Whatever the truth, one thing became clear. Every time the best cameras looked directly at it, the universe blinked. It was not destruction, not malfunction, but silence, an intentional stillness that kept its secrets intact. And so, amid the age of high resolution, when we can see galaxies billions of light years away, this single visitor from beyond the stars remained hidden in plain sight. Perhaps the silence was not failure at all. Perhaps it was protection. Because sometimes the things that do not want to be seen know exactly when the world is watching. When the first set of positional maps from 3IATLAS arrived, no one noticed anything unusual. To most astronomers, it looked like a normal orbit, a clean arc across the solar system, bending gently as it passed near the sun. But then came the overlays. A graduate student comparing starfield charts to Atlas's recorded path noticed something eerie. When she traced its movement frame by frame, the curve wasn't random at all. It aligned with a series of fixed stellar coordinates, forming straight lines and perfect intersections. She thought it was coincidence until the pattern repeated on the next rotation of data. Over the following weeks, other researchers began checking. The same geometric alignments appeared again and again. When plotted across time, the path of 3IATLAS formed shapes, triangles, hexagons, even spirals that matched known mathematical ratios. This was not the messy, natural scatter typical of comet motion. It was geometry, precise and intentional. At first, the community dismissed the findings as pareidolia, the human tendency to see order where none exists. But when multiple observatories, each using different software and calibration methods, produced identical geometric overlays, the tone changed. The alignments were real. The question was why. Comets respond to gravity, sunlight, and their own internal jets. Their paths curve naturally under these forces, but never with architectural precision. Yet 3IATLAS seemed to know where the stars were. The angles of its trajectory aligned with bright stellar landmarks like Vega, Deneb, and Sirius, repeating across several observation windows. Each alignment lasted only a few hours, then shifted to the next as if following a script written across the heavens. An astronomer from Madrid compared the timing of these alignments to known mathematical constants. What he found was unsettling. The intervals between geometric formations matched the Fibonacci sequence to several decimal places. When projected forward, the pattern predicted where the comet would appear weeks later with uncanny accuracy. The numbers seemed to guide its motion, as if an invisible hand had built its path using a hidden code. Other scientists tested this idea further. They superimposed the trajectory over planetary longitudes and found repeating ratios that mirrored ancient geometrical harmonies. The same ratios that describe the orbits of Venus and Earth, the same patterns encoded in the pyramids and megaliths on our own planet. It was almost as if 3IATLAS had been designed to echo the architecture of creation itself. Skeptics warned against romanticizing the data. They argued that statistical coincidence could explain much of it. Yet each new discovery chipped away at that comfort. The more precisely the comet was tracked, the more intentional it appeared. During one window of observation, its movement traced a near-perfect equilateral triangle across the sky, each vertex pointing toward a major constellation tied to navigation in ancient cultures. The odds of such alignment happening by chance were astronomically small. Even more disturbing was how these geometric figures appeared in 3 dimensions. When the data was rendered spatially, the shapes extended through the solar system like invisible scaffolding. Lines of motion crossed orbital planes with perfect angular symmetry. Some of those intersections occurred at distances corresponding to harmonic ratios used in sound frequencies and quantum resonance. The comet was not just moving through space, it was composing through it. In one secret symposium held in Geneva, a physicist proposed a theory that sent a chill through the room. What if 3IATLAS was not traveling freely, but following a geometric grid that pre-existed within space itself? A framework we had never detected because we were never looking for it. If true, it would mean that interstellar motion is not random at all, but bound to invisible architecture, an ancient geometry of the cosmos that only certain objects can reveal. This idea was later called the celestial blueprint hypothesis. According to it, 3IATLAS could be mapping or activating nodes within this grid, passing through specific coordinates that generate harmonic resonance between celestial bodies. To most, this sounded like pseudoscience. Yet the data fit. Every major shift in its brightness occurred precisely when it crossed one of these geometric nodes. Further analysis uncovered another strange correlation. During several of these alignments, Earth-based instruments recorded subtle fluctuations in gravitational fields. The shifts were tiny, far below normal noise levels, but they occurred in rhythm with the comet's geometric transitions. It was as if its movement was tugging at the invisible fabric of reality, moment by moment, line by line. Astronomers also began noticing that during each alignment, the surrounding sky seemed unusually still. The background noise of cosmic radiation dropped, and plasma flux in the solar wind flattened into smooth curves. Even the sun's minor flares softened briefly before returning to normal. The phenomenon resembled a kind of spatial quiet, as though the universe itself paused whenever 3IATLAS aligned with its invisible geometry. To some, this was proof of a hidden mechanism, a celestial machine operating far beyond human understanding. Others feared the implications. If such geometry governed cosmic motion, it might also influence energy, magnetism, even consciousness. Ancient civilizations had long described the heavens as a living clock, a structure of divine proportion. Could it be that 3IATLAS was demonstrating that those old myths were closer to truth than we ever imagined? When the comet entered its outbound phase, the geometry became even more defined. It began forming repeating loops that, when connected, traced a complex mandala-like shape across the sky. The design mirrored sacred geometry found in temples across multiple ancient cultures. It was as if the same ratios that guided human architecture were now being drawn by a traveler from another star. Meanwhile, deep space sensors detected faint electromagnetic pulses at each geometric intersection. These signals were weak but structured, carrying consistent frequency spacing. Some scientists speculated that these could be byproducts of magnetic realignment or plasma resonance. Yet others wondered if they were messages encoded in geometry, the universal language of the cosmos. A group of data analysts from Japan ran pattern recognition algorithms on the pulse intervals and found repeating mathematical sequences that corresponded to prime numbers. This discovery reignited debates about intentional design. Prime numbers are rare in nature, yet central to communication protocols. If 3IATLAS was transmitting, geometry would be the perfect carrier, visible to any civilization advanced enough to decode it. As excitement grew, skepticism turned into unease. The geometric forms were not just mathematical abstractions anymore. they began to manifest visually in composite imaging. Long exposure photographs revealed faint hexagonal halos around the comet's path, as though the dust and plasma were arranging themselves into shapes dictated by unseen fields. The geometry was literally appearing in the sky. Observers described the sight as hauntingly beautiful, a lattice of faint lines glowing softly like a celestial fingerprint. Some said it felt as though the universe was drawing with light, revealing patterns we were never meant to see. Others compared it to a message, an invitation, or a warning, written in the only language shared by every civilization that ever looked at the stars. Then, just as quickly as it appeared, the geometry began to fade. The comet's trajectory loosened, the alignments dissolved, and the dust clouds returned to randomness. The symmetry was gone, but those who had seen it could not unsee it. The data remained undeniable. Every point of alignment, every ratio, every harmonic pulse existed in the record. And though official reports labeled it as visual coincidence amplified by observational bias, private conversations among astronomers told a different story. Many admitted they could no longer look at the sky the same way. It now seemed less like an infinite void and more like a design, an equation too vast to comprehend. What 3IATLAS revealed was not just geometry, but intention. Whether that intention belonged to the object itself, to the structure of space, or to something even greater, remains unknown. But one truth stands quietly above the noise. Geometry is order, and order implies a mind behind it. Perhaps when 3IATLAS traced its perfect shapes across the night, it was not performing a random dance of physics. Perhaps it was leaving behind a message older than language itself, a reminder that in every orbit, in every pattern, and in every ray of light that crosses the heavens, there may still linger the signature of intelligence, written not in words, but in the geometry of creation. It sounds like science fiction, yet the test is simple enough that anyone with patience, a telescope, and a bit of curiosity could attempt it. The theory behind it emerged quietly among astronomers who refused to let the mystery of 3IATLAS fade into rumor. If this object truly operates under rules that hint at design, then its behavior should be predictable. And if it is predictable, then it can be tested. The idea began with a question whispered in private meetings and encrypted messages. What if the patterns in 3IATLAS's light, geometry and timing are not random emissions, but responses? If the comet is reacting to solar activity, geometry, or even our instruments, then we should be able to provoke a reaction, something measurable, something undeniable. The simplest version of this test involves light. When 3IATLAS reemerges from its current blind spot behind the Sun, a network of small telescopes could observe it simultaneously from multiple continents. The key is synchronization. Every telescope records brightness fluctuations down to fractions of a second, sharing timestamps through coordinated atomic clocks. If the comet's flicker pattern repeats in intervals of clean ratios or synchronizes with solar data again, that would confirm a deliberate pattern. But the more ambitious version of the experiment goes further. It proposes transmitting specific light pulses toward the region where the comet is expected to appear. These would not be messages, but neutral signals, controlled flashes of different durations projected by high-power lasers used in astronomical calibration. If 3IATLAS responds with mirrored or modified light behavior, that would suggest something extraordinary. Of course, few scientists are willing to put their reputations on the line to test a theory that borders on the impossible. Yet the plan has quietly circulated in closed astronomy groups. Some refer to it as the mirror experiment. Others call it the echo test. Both names describe the same hope: to see if the universe will blink back. It begins with preparation. First, locate the predicted coordinates of 3IATLAS. Its faint glow will likely appear again in the early morning sky, low on the horizon before sunrise. Amateur astronomers can join by pointing small telescopes toward those coordinates and logging brightness data. The comet's returning tail should appear greenish-white, faint but distinct. Second, record continuously for as long as possible. The object's previous blinking cycles lasted anywhere from 5 minutes to several hours. Look for repeating peaks in brightness and compare them against solar flare reports from agencies that monitor space weather. If you find synchronization again, even at a small scale, it would confirm that the connection persists. The third step is to test for local resonance. In simple terms, it means checking whether the object reacts to frequencies on Earth. During its last observed synchronization, subtle electromagnetic fluctuations were detected in the Schumann resonance range. Some researchers suspect that the comet may respond to these low-frequency waves, which form the Earth's natural background heartbeat. By monitoring resonance levels during observation nights, we may find correlations. None of these steps require advanced equipment. They demand patience, cooperation, and open minds. The real beauty of the experiment is its accessibility. It strips away the secrecy that surrounded official investigations and gives the mystery back to the public. Anyone can participate. Anyone can look up and test for themselves, yet the deeper implication is far more haunting. If the comet does respond, even once, it would mean that space is not as silent as we have believed. It would mean that 3IATLAS is not just a frozen relic from another star, but something interactive, something aware of its environment in ways we cannot yet explain. To those who dismiss the idea, it helps to remember that the first evidence of pulsars once appeared to be artificial too. In 1967, astronomers detected radio signals repeating with perfect precision and nicknamed them LGM, short for Little Green Men. Only later did we learn that they were spinning neutron stars. History teaches that strange patterns are often the first hints of new physics. The universe reveals its intelligence through rhythm and timing long before we understand it. If the mirror experiment succeeds, the next phase would involve triangulation. Multiple observatories could analyze whether the comet's light changes depending on where it is being observed from. If the object interacts differently with different angles of observation, it could indicate a form of directional awareness. Imagine a natural system that senses how many eyes are watching it. Such behavior would not fit within any known cometary physics. One theoretical physicist proposed a more daring idea. Perhaps 3IATLAS is sensitive not to light itself, but to the act of measurement. Quantum experiments on Earth already suggest that observation can alter outcomes. What if the comet operates on a scale where cosmic measurement produces macroscopic effects? If true, this would redefine the boundary between physics and consciousness. Skeptics argue that these are philosophical fantasies, yet even they agree that verification is needed. A repeatable test run transparently would end speculation one way or another. If the comet's light curve remains random, the mystery fades. If it repeats, the world will never see the sky the same way again. Another variation of the test focuses on geometry. Using orbital simulations, researchers have identified the next few coordinates where 3IATLAS is expected to align with major stars. By marking these alignments in advance and observing whether the comet brightens or pulses at those precise positions, we can test whether its geometry is deliberate. If it follows the same harmonic intervals as before, we will have confirmation that its previous behavior was not coincidence. Some have even proposed monitoring Earth's electromagnetic field during those alignments. In earlier observations, small resonance spikes appeared in magnetometer data whenever 3IATLAS crossed one of its geometric nodes. The connection may sound impossible, but if those spikes reoccur, it could reveal that the object interacts with space itself through patterns we barely understand. To the casual skywatcher, this all sounds poetic, even mystical. Yet beneath the mystery lies hard science. The idea of resonance and feedback between cosmic bodies is not new. Stars influence one another through gravity and radiation. Planets vibrate with electromagnetic harmonics. The possibility that a comet could act as a bridge in that network is not as far-fetched as it sounds. There is even a human element to the test. For centuries, people have looked at the heavens seeking meaning. We built monuments aligned with stars, mapped patterns in constellations, and believed the cosmos could speak. Now, technology allows us to ask again, not through prayer, but through data. If something in space truly echoes our signals, it would mark the first conversation between matter and mind on a galactic scale. Imagine the moment. Telescopes from 5 continents pointed toward a small, glowing fragment beyond Mars. A pulse of light fired into the darkness, followed by silence. Seconds later, a faint flicker returns, matching the rhythm of the signal sent. Not noise, not coincidence, but an echo. A whisper from an object millions of kilometers away saying, in its own silent way, that it is aware of being seen. Such a moment would change everything. Not because it would prove extraterrestrial intelligence, but because it would reveal intelligence woven into the universe itself. A self-organizing awareness that bridges physics and intention. The test could happen tomorrow. You do not need access to a government observatory or secret data streams. You need curiosity, timing, and the courage to look beyond what seems impossible. Start by learning the comet's next coordinates. Watch the solar weather feeds. Note the times when the sun flares, when Earth's magnetic field stirs, and when 3IATLAS glows. You might discover that these events still move together like gears in an unseen machine. The silence of the cosmos has always been humanity's greatest mystery. But silence is not the same as absence. Sometimes, silence is the language of those who wait for us to learn how to listen. Perhaps 3IATLAS is not here to reveal itself fully. Perhaps it is here to teach us how to test the unknown with open minds. A simple observation, a shared night under the same sky, could become the turning point in how we see our place in the universe. So tomorrow, when darkness falls, step outside. Look toward the faint green shimmer near the horizon. Somewhere out there drifts a messenger older than memory, following geometry no chart has ever mapped. And maybe, just maybe, if you pay attention long enough, you will see it blink. Once, quietly, like the universe acknowledging that you have begun the test.